Okay, let's start your with two answers. Paper number one. Okay, verify the identity. So I think this should be 1A. 1A. So tangent with the power of 4, tangent squared, secant to the 4, secant squared. How to verify? You can go from left or right. That would be similar results. But what will you do? What is the first idea to verify the identity? Okay. Hmm? Change? Which one? Yeah. Which one you need to change? With what? What? Yeah, what? Hmm. Yeah, what? What do you write? You just say this, but you didn't write anything. What? Right, just right. Okay, so you need to change which one, 10 or second? You can do both. Okay. Okay, listen. If you if you are not familiar with the trigonometry, sine, cosine, tangent, secant, how to relate all of them, I'm suggesting you to take this course again. I cannot uh, have you move forward because it's very basic. Okay? So you need to know first, okay, the first identity in the trigonometric, okay, that you can prove with Pythagorean. I will write this first, okay, so you get the idea. Okay, let's multiply all with, okay. Now this become one, okay, and this become 1 over cosine squared. Okay, so this is how you are uh, relating the basic identity in trigonometry with the other one. Okay? And we can write this as tangent squared theta plus 1 is equal 1 over cosine squared is secant. Okay. Now for the for verifying the questions, we can use this identity. You can use the tangent or you can use the secant, okay, to change. Okay. Let me write tangent squared theta is secant squared theta minus 1. Okay, let me write from this particular information. Okay, let's just square this both. It will be tangent 4. So this is my tangent with the power of 4. Okay. So you can do the tangent or the secant 4. It's both in on the equations, right? So you can do from both sides. So let's put all the informations. So secant, I will change the left side. So secant 4 theta minus 2 secant squared theta plus 1 plus tangent squared theta. This is secant squared, right? So it's proven that this is okay. Okay, got it. Okay, but you can also use the secant 4 and moving this to the left side and then change the secant 4 with the tangent. That's also the same result. It should be the same. Okay. Number 2 is number B is 1 minus sine 1 plus sine theta. This should be equal to secant theta minus tangent of theta. Okay, now number 2. How about this one? Where will you start? I think left or right should be the same. Let me expand this first. Okay, so giving more idea. The secant squared minus 2 secant theta tangent theta and plus tangent squared theta. Okay. Okay. Now the right side, if you see it's all secant, secant, tangent, tangent, which means you will get the secant is 1 over cos. This is 1 over cos, sine over cos. Tangent is sine over cos. You can manipulate this form, and maybe somehow you will get the sine plus sine. You will see that the bottom, if you make all into the cos, it will have all cosine, right? At least cosine squared. Make it cosine squared. If you have cosine squared, you can get 1 minus sine squared. 1 minus sine squared is 1 plus sine, 1 minus sine. Somehow you will get this 1 plus sine. But another thing, if you have the fractions like this is having minus plus, okay, you need to change this form and see this is minus, this is plus. If you want to make or you want to erase the bottom side, you need to make the bottom at least having 1 minus sine squared. So it will become a cosine squared. And somehow maybe it will be, you can rewrite the form and make it into secant. That's the idea. Okay. So it's not just all the steps that you write down, and maybe you are writing in cycles and you didn't prove anything. Sometimes it happens. Okay. So in fractions like this, you have minus, plus, and you want to make it squared, you need to multiply. We call it rationalization. I think in calculus, I already mentioned that. It's called rationalization, in which the bottom side, you need to multiply with the opposite signs. Okay? Multiply with opposite signs. So let's do that 1st. Okay, let's multiply with this one. The top one is just like 1 minus sine theta and then squared, and you can expand that form. And the bottom side, it will be, it's positive and negative, so it will be 1 minus sine squared. Okay, 1 minus sine squared. Let me make some notes here. So 1 minus sine squared theta. So I will write the bottom is cos sine squared theta. Okay, and the top one is like a quadratic functions. So 1 minus 2 sine theta plus sine squared theta. Okay. And then let's solve 1 over cos and separate all of them. Okay. 1 over cos squared becomes secant squared. And 2 sine, let me write 2 sine theta cos theta, and then 1 over cos, right? Like this. This becomes tangent, becomes secant, right? Minus 2 tangent theta secant theta. And then plus tangent squared. Is it the same with this? Same, right? So I can write this, or writing back to this formula. So it's proven. Okay. This also you can prove from here. Okay. If you want, you make this 2 over cos theta sine theta and then cos theta and then plus sine squared theta cos squared theta, and then you get all cos squared. You get 1 minus sine squared. You get 1 minus 2 sine theta plus sine squared theta, right? And you get this become 1 minus sine theta, 1 plus sine theta, and the whole thing here is, and that's all proven. Okay, as you can do from right, from left, it's up to you. But I prefer, if I was nervous, I will go from the left side. This is you need to imagine the form, okay, a lot. But if you prefer the right side, that's also okay. That's also good. So you can go from left or right. Okay, that's number 1. Any questions? Okay. So trigonometry, you will at least getting used in other courses too, right? Like I think for now it's just physics, calculus, but maybe in the next future you will learn high level math, like engineering of math, or maybe the concept for kinematics. In any course that has concept of kinematics, you need to master the trigonometry. Okay, and if you still confused like how secant theta become 1 over cos, then I'm suggesting you relearn all the basic concept. Okay? So that's number 1. I think most of you are able to solve this one. Okay, number 2. Number 2 is what? The amplitude, right? So y is 2 sine Okay, so the questions is the amplitude is it's 2. Okay, the period is it's 2 pi divided by k. Okay, k is what? It's half, right? This is k, so it's 4 pi. And phase, okay, for phase, uh, there are some differences with other terms. It's phase, not phase shift. Different. Okay? Phase is the difference at the steady state. Okay. So phase is actually just this pi over 6. Okay. But it is different from phase shift. Phase shift is the same as horizontal shift. Okay. So the other one is horizontal shift. So horizontal shift is if you want to write the formula with the k outside, then it should be this, right? So this is the pi over 3 is the horizontal shift. So you can say that the phase is actually horizontal shift multiplied by the k. It's actually phase. Okay. And then number 3, and so this is the information, and the question is cos x plus sin x. Actually, I should tell you the at least the options that the form should be. Okay. But let me explain to you. Okay. First, the cosine minus sine, let squared. Okay, both sides. Okay. A lot of you did this thing, and it's correct. Okay, the squared is correct because if you did this, then you get cos squared x minus 2 sine x cos x plus sine squared x, and it's equal to sine squared x. Okay, cos squared plus sine squared it's become 1. Sine x cos x it's become sine 2x, right? Let me move this. Okay, so I will write this become 1 minus sine 2x. Okay, is equals 2 sine squared x. Okay. And stop here. Stop here. Do not manipulate the form. Okay? Stop here first. Okay. And now look at the second one, the question. Okay. The questions, let's square this. Okay. Let's square this. Because cos sine, the difference is only minus and positive. So the end terms should be similar, right? It has cos squared and sine squared. It's also cos squared and sine squared. Okay. Okay. It's become this. Okay. Now listen. This similar, and this also similar, right? It's 2 sine x. 2 sine x cos x, right? Okay. Let me write this become 1 plus sine 2x. Okay. Now I can move this sine 2x and substitute the sine 2x here. Okay. Let me write the sine 2x from here is sine 2x is 1 minus 2 sine squared x. Some of you are, oh, this is cos 2x, but you changed cos 2x, but why you need to change that? Just leave it 1 minus 2 sine squared x and move this to here. Okay. So 1 plus 1 minus 2 sine squared x. This becomes 2 minus 2 sine squared x. And it is the 2 cosine squared x. Okay. And this is the cos x plus sine x squared. Okay. So cos x plus sine x is, actually this is the answer that I want. Uh, but actually, you can look the real number if you want. Some, I think 2 or 3 students did that, and that's correct also. So I should put the options in the number 3, and I want to get this square to cos x. If you want uh, to make the number, if you see cos x minus sine x squared to sine x, let's divide by sine. Okay, this becomes cotangent minus 1 is equal square root of 2. And so you have the cotangent and you have the number, and you can relate the cotangent and then put back here. So the answer is a number with square root of 2. That's also possible, having the number. Okay. So let me write, but I won't write all. So this becomes cotangent x minus 1 is equal square root of 2. So cotangent x is square root 2 plus 1. And then you can change this and relate to the cos x plus sine x. And you will get also the number, okay? The exact number. But actually, I don't need that the real number. I just keeping here, okay? Because it's easier to relate, okay, from the cos x minus sine x and the cos x plus sine x. Okay. So I think I forgot to mention the options for the answer. So I will give you some points. Okay. Okay. Now is the number 4. Number 4 is the polar curves. The R is number A, 2 sine 2 theta, and R equal 1. Okay, it's sine and it has 2 theta, so it's even, right? In even, this form is the rose, the flower. It has 2 multiplied by 2, 4 petals. Okay? And in sine, because it has 4, and it should be like this. Okay. Okay. Let me draw the triangle, the circle first. Now so I'll write in this part is r equal 1, r equal 1, and yeah, more or less should be the rose with the 4 petals. And the question is actually, aside from sketching the curves, you need to point out the intersection. Okay? It has 8 intersections. This intersection. Okay. And how to find? You can solve the equations, equaling them, and you get the equations, and you get at least you get one angle. Let's say it's pi over 12, and the other angle should be because it's sine, so you need to find the where the sign is, the other sign is positive, right? And then you can add the plus the repetitions. Okay? So you get the pi is n plus 1 over 12, and theta is pi n plus 5 over 12. So this is the intersection. And number B, I'm giving you x squared plus y squared, and then squared, and then x squared minus y squared. And I think most of you are didn't remember the form. So actually, this is not a rose, uh, not a cardioid or a limison. If we are thinking in a polar, x squared plus y squared is the radius squared. Okay, so this is radius squared and then squared, and then this part, the x. Let me change the x into r cosine. So r cosine theta squared minus r sine theta squared. So let me just write r squared squared, and then this is r squared, and then cos squared theta minus sine squared theta. Okay, and I can cancel this, so I can write the form becomes r squared equal the cos squared and minus sine squared become cosine 2 theta, right? And this is the form for lemniscate. Okay, most of you didn't remember the form, but I think a few of you draw this correctly. So the drawing should be, because it's on the constant here is only 1, so the distance is 1. So this is the yeah. So this is the distance is 1, and the r is maybe around here. So this is r equal half square root of 2. And we can solve it. So squared is cos 2 theta. So we get this is half is cos 2 theta. So 2 theta is pi over 3. So theta is pi over 6. Okay? And so the theta will get in the intersections at the pi and the other one is and plus 1 over 6. Because cosine is in the quadrant, the first quadrant and the fourth quadrant. Okay? The fourth quadrant is this minus. Okay? Hey, please don't forget the polar curves. Calculus 2, you will you will solve the polar curves and with integrations. Okay. Number 5 is you have the polar, and it's said to prove the proving the circle equations, right? So you get r, and then you get cosine and sine. But first, if you remember the circle equation, let me write the circle equations. Okay, should be this, right? Should be r squared x squared plus y squared. And you need to also remember the x is r cos theta and y is r sine theta. Okay. Now in this equations that the given, okay, you have a and b, which is the constant, okay, which is the constant. So it's not a radius. So we need to multiply with the radius so that this become r squared and this become ar cosine br sine. So r cos and r sine we can change to x and y. Okay. So what we need to do is we need to change this form and make it into a circle. Okay. So let's multiply by r. Okay. So and then you get let's make the r squared become x squared plus y squared, and this become ax plus uh, by. Okay. Most of you stop here. Why? Why? So to solve this, group each x and y. Okay, grouping each x and y. Okay, this is very basic quadratic functions problem, basic ones. Okay, so plus y squared minus by. Let me uh, move here. And we solve it to complete the standard form of the quadratic function. What we need to do is to see here a and b, divide this by 2, and then square. It's called the complete square. Okay, so divide by 2 and then square. So plus uh, a over 2 squared. Okay, and then this also plus b over 2 squared. And because we plus on the left side, on the right side, we need also plus them. Okay, so plus the a over or a squared 4 plus b squared 4. Okay, and this is perfectly become our standard form of quadratic functions. It's become x minus a over 2 squared plus and it's equal 1 over 4 a squared plus b squared. Okay. So this is the circle, x squared, y squared, and then this is the radius squared. Okay. So the center should be a over 2 and b over 2, and the radius is square root. This becomes the square root, so half, and then square root of a squared plus b squared. Okay, got it? Okay, so don't forget the how to solve the quadratic functions. Okay, okay, number 6. We have the parametric 2 sine, and then 4 plus cosine t, and the t is evaluated at pi over 2 until 3 over 2 pi. Okay, first of all, if you want to solve the parametric and change the rectangular uh, coordinates, if you have sine and cos, you need to solve by squaring the sine and cos. Okay? So make it the solution for sine is x over 2, and cos t is y minus 4. Okay. Let me square this and square this, okay, and square this and square this, okay, and then plus, okay, and this become 1 x squared over 4 plus y minus 4 squared. This is what? An ellipse, okay, an ellipse. At least you know this ellipse, okay, because it has something here and equal 1, okay, some constant below the x. But it's not in 0, 0. It's on 0, 4. Okay. So what you need to do, you can put it. So maybe 4 is here. 4. Let's say this is 4. And the bottom one will become the distance. Okay. So this should be 1, 1. Okay. And then 2 here, the x1. So at least if I want to draw the full ellipse, this is the full ellipse. Okay. And in exam, you don't need to draw really like smooth and correct. No, I just want to know how the motions look like. Okay. That's okay if not perfect, but it should be at least similar to this ellipse. Okay. And then from t pi over 2, actually you can also use the table. Okay, you can also use a table, and you can check the pi over 2 and then the endpoint 3 over 2 pi. Pi over 2, you get x is 2. Pi over 2, you get 4. From here, get 4, 2, 4, maybe here. Okay, the starting point, pi over 2. So this is t equal pi over 2. And the endpoint is 3 over 2 pi. And it should be around here, okay, if you plug in the number. And if you want to make sure, you can check pi, and it will be here. It's on 0, 0, 0, 0, 1. And then what you need to do is just making the motions from from right to left. And the arrow in parametric is important. So you need to draw the arrow. Okay. This is how you describe the motion. It goes from t pi over 2, and the motion will be an ellipse from right to left. And don't forget the arrow. Okay, okay, that's number 6. I was expecting you have most of you are getting correct in this one, but I think I I hope too much from you. So yeah, because this is very simple, right? Very simple, but I think I was expecting too much. It's very simple. I believe this is high school. Okay, but don't worry. Okay, let me draw the picture first. Okay, this is square root of 3 meter. The building is 7 square root of 3, and this is h. The questions, right? Asking the height of the flags. The the ground is square of 1 meter. And I already draw in the front. So I don't know. Only a few get correct. This is alpha. And this is beta. Okay. So first, the obvious thing is the square root of 3, and then uh, this 7 square root of 3. So you have a triangle, right? You have a triangle. Now let me draw the triangle. Let me draw the triangle. So let me check. Let me check. Okay, let me check. This should be this, right? But why some of you are not calculating this? What is this? Results. Yes, 6 squared of 3. Okay. Why you're not calculating this? Okay. Come on. This is maybe elementary. Come on. You are in university. And do not square of 3, 3, oh, 3 minus 3, 0. Do not write like that, okay? I believe I have this problem in this class. This. Why you're writing this? Okay, please, please. You need to check your math, okay? I If you still cannot catch up until the last semester, I need the students to redo the course, the basic math course, okay? Because this is really fatal. It's fatal, okay? Okay. At first, I think, oh, maybe it was because nervous, but it's not because most of the problem he did the same mistakes. So the problem is not because of he's in nervous because the exam, but because he don't know. That's the problem. Okay. So this is 6. Okay. 6 squared of 3. Okay. And this is still 5. Okay. And you have the Okay, let's make this alpha and beta. Okay, you already have this ground and this side. Okay, you already have alpha, beta, and I said it's complementary, and I already, I think I mentioned and write down. So alpha plus beta should be 90. Okay, because it's complementary. It's complementary. Okay, that's what it means. So in the next future, if you read any text problem and said it's complementary angle, meaning it's if you add the angles, it should be 90. That's complementary. I believe it should be in junior high school. It's junior high. Come on. So alpha, beta, you have this ground and this side. Do not think too much and you write and find this hypotenuse. For what? For what? That's the question. For what you need to find here. You already have this. So use tangent, tangent. Okay, use tangent, tangent. Tangent alpha. Tangent alpha is this, right? And how about tangent beta? Or let me write alpha plus beta is 90. So beta is 90 minus alpha. Okay. So tangent beta is equal tangent. Okay. So tangent 90 minus alpha. If you like, maybe you need to calm yourself. Or what is this about? Okay. Let me write the sine a sine. Okay. In sine and cos, because they both complementary. Okay. They both complementary. The difference is 90. So if I have sine 90 minus alpha, it's become cos alpha, right? Remember, I think high school is cos alpha and sine alpha. So basically, you just flip this around, right? The tangent is become the cotangent. So tangent beta is equal, and from the picture we get the tangent beta is 6 square root of 3 plus h over, and we get this expression and solve the height. Okay. And to solve this, you just to cross multiply. Okay, cross multiply. So 6 squared of 3, 6 squared of 3. How to multiply this? I believe you have some error. This one more. A few students get this, and I give a lot of points, but he still make a mistake to solve this. Okay, maybe nervous. I believe that nervous because he understand this one. That's nervous, not knowing the concept, but it's nervous. Okay, this difference. Okay, knowing the concept and not knowing the concept. Well, maybe knowing the concept but nervous, but still not knowing the concept and nervous, and okay, you will be totally. I cannot give really any points because I think you don't really know what you are writing if you don't know the concept. Okay, so 6 square of 3, 6 square of 3, 6 is 36. Square of 3 is 3. 36 multiplied by 3 is 108, right? 108. So 108 plus 6 squared of 3h and then equal 135. 108, 135, 27. Okay, and you can just solve it casually. And then h, if you just write this, that's still fine. And if you want to simplify, you can simplify until you get the answer is 3 over 2 squared of 3. Okay. And this is the answer. Okay. So that's the quiz. Okay. If you get around ranging from 35 to 40, that's good. I already mentioned yesterday. That's good. Okay. If you get more than 45, maybe 50. Okay, that's better. You get more than 65. That's excellent. Okay, excellent. Because I already count that maybe you will skip one or two questions. So maybe I maximize the point. But if you are getting below 20, below maybe 25, below 25, it means you are not really understand. You are not really understand. So that's the quiz. So if you want to get your results, you can come tomorrow or just wait next Tuesday if you want. But if you want, you can come tomorrow, maybe 10:20, I will be in the office. Okay, let me go back to the matrices, okay, to the matrices. I will upload the notes for the answers in the Moodle system. And let me go back to the matrices. Okay. Okay, if you have A, B, okay. So let's multiply A and B. Okay. So it's two matrices. This is three matrices. Okay. So for the matrix, like I said yesterday, like I mentioned, if you have the matrix you want to multiply, you need to multiply the row and the column. Okay? The row and the column. And you need to understand the structure of the matrix. Okay. If you have two and two rows, two columns, and then you have two and three, basically the result you will have is these two is canceling. Okay. So this is the procedure. Okay. So you need to have the same amount of this is the column and the row and column here. These two. Okay, this should be the same. Okay, let me write this as notes. Okay, should be the same. So the result should be 2, 3. Okay. So 1, 3, and negative 1, 0. 1 multiplied by negative 1 is negative 1 plus 3, 0, 0. So negative 1 plus 0, negative 1. Okay, so this part negative 1. Okay, you can feel going down or going right. Let me going down first. Negative 1, negative 1 is 1, positive 1. 0, 0, 0, so it's just 1 here. Okay. And then 1, 3 to 5, 4. 1, 5, 5 plus 12. 5 plus 12 is 17. And negative 1, 0 to 5, 4, negative 1, 5, negative 5, 0, negative 5. 1, 3, and 2, 7. 1 multiplied by 2, 2 plus 21, 23. And then negative 1, 0 to 2, 7 is negative 2. Okay, so that's how you are multiplying the matrices. Okay, row and column, and it's become the bottom and left, right? So it's become here, row and column in the middle. So it's become the bottom and then the middle. Okay, I hope you get the idea for the matrix structure and how to multiply. Okay. Okay, let me write BA. Let me draw. Let me write the B. This is 2. Can we do this? Can we do this? Why? The row and column, right? So it's 3, but it's only 2. So you need to have one more. So if you add more here, you can do that. But here it's cannot. Okay? It's cannot. So this is 2, 3, and this is 2, 2. So this 3 and 2 is not the same. So you are unable to multiply these matrices. Okay, let me give you another point of view for the multiplications. Okay. Let me give you another example for matrices. Let me give you just two matrices and also B also two matrices. Okay, so let's start with AB. Okay, let me write the full terms. So this A and B. Okay, let's write down the results. So it's 2 by 2 and 2 by 2. So the result should be 2 by 2 also. Okay. So 5, 1, 5 plus 63, 68. And negative 3, 1, 0, 9 is negative 3. 5, 2, 10, 10, negative 7 is 3. Negative 3, 2, it's negative 6. Okay. Let's try the BA. Okay. 1 to 5 is 5. -6 is -1. 1, 7 to 0 is 7. 9, 5, 45 plus 3 is 48. 9, 7 is 63. Okay. See, the result is different, right? So AB and BA is not the same. This is important property for matrices. AB not the same as BA. So that's the algebra of the matrices. Okay. Um, I think I haven't mentioned. If you plus A plus B, what you need to do is just plus each one. Okay. If it's this equal matrices, okay, you can plus them or subtract. It's okay. If you want to multiply by the scalar, like maybe the constant, you can multiply all with the constant. That's fine. But if you multiply AB and multiply BA, the result is different. So it's not the same when you multiply. Okay, that's the algebra of the matrices. The next one is called the identity matrix, or we are writing the identity as I, the big capital I. This is the and matrix for which each main diagonal entry is 1, and all others is R0. Which means if you have two matrix, this is the identity. If you have 3, this is the identity matrix. So if you multiply the identity with any matrices, it will stay as the matrices. Okay, so maybe you have for example, this 1, 2, 3, 4. If you multiply this 1, 1, 2, 1, 1, and 2, 0, it's become 1. 1, 0, and 2, 1, it's become 2. It's become the same thing as the original function. Okay, that's the identity matrices. So if you have A and you multiply by the identity, it will still be A. If you have B, still B. So from right side or from left side, it should be the same as the original original matrices. Okay, why this important? This important to define the inverse of the matrix. Okay. But this is identity matrix, and the next one is the inverse of matrix. Let A, the matrix A, is n by n matrix. So if there exists, okay, a inverse, okay, a with n matrix, then you have the property a a inverse is the same as a inverse a. It's the same as the identity matrix. Okay, if A is uh, A, B, C, D, the inverse is defined by so this is the inverse. If AD minus BC is 0, A has no inverse. Okay, now I would like to explain the inverse. Okay, so um, this identity is really important. So if you have the like for example, uh, the inverse for 2 matrix is I think it's not too. If you see the form, I think it's doable, and it's not like a big matrix. At least for inverse, we will learn until the 3 by 3 matrix. Okay, it's 2 by 2 and 3 by 3. Um, let's say we have the matrix A. Do you still remember how to find if you have 3 by 3 and you need to find the inverse? You still remember? The determinant will be depends on your yeah. You can like the or you need to write the and cross multiply, right? But let me tell you about the how we relate the 3 by 3 matrices, or maybe if you have 2 by 2, to the augmented matrix that we have learned before, the row echelon form. Okay. Okay. Now let me write the row echelon form. 1, 2, 3. Let me write with different. Okay. This is the identity, right? With 1, 1, 1, 1. Okay. You have the idea that uh, A and A inverse is identity, right? And A inverse A is also identity. Okay. Okay. See how we can relate this. A inverse identity, A inverse A identity also. Okay. So if we flip, okay, if we switch and use the the elementary process, okay, you have 1 1 1 and 0 0 0 0, right? Do the operations, the row echelon form like yesterday I told you. Make the left become this. Do the operations. Plus, subtract, multiply, anything you want. That's also one thing to do to solve the inverse. If you get the left side 1 1 1 0 0 0 0, the right side will be the inverse. You get the idea? Okay. From this identity. Okay. So if you solve this and you are making this become 1 1 1 and this become another number, this right side will become the inverse. There's another thing. If you want to solve through the augmented matrix and row echelon form. Okay. Let me write this in the another slide. Wait. So we will define the inverse through the augmented matrix first, and then we will go back to this one because this AD minus BC is called determinants. It's called determinants. We will go back to here next section. But now let me explain this. So to make the other part 0 and this part also 0, uh, I think if these two we can compare to this the first one, 2 and 1 and 3 and 1, right? So 1 we can multiply by 2 or 3, and then we can subtract and becoming 0 in these two. Okay, let me write. Okay, let me write. So R2 minus 2R1, and then this become R3 plus 3R1. Well, let me check the, oh, sorry. This should be -3. Okay. So R2 minus 2R1. So R2, 2 minus 2 is 0. Minus 3 plus 4. It's 1. Minus 6 plus 8 is 2. And this will be 0 minus 2, it's minus 2. 1 minus, it's still 1. No, still 0. Okay, R3 plus becomes 0. 6 minus 6 is 0. Yes, it's good number. So 0, 0, 0. So 15 plus negative 12. So 3. And 0 plus 3 is 3. 0 and 1 and still 1. Okay. Oh, we can divide by 3. So it's become 1, 1, 1. Okay, so 1 and 1, 1/3. So this become 1, 1 and 1/3. So this should be divided by 3. So R1. Now what we need to do is we need to make it this 3 become 0. So the idea is maybe from this negative 2 and 1 and multiply by 2. Negative 1 plus 2 is 0, right? So R1 plus R2. 2R2. So 1, negative 2 plus 2 is 0. Negative 4 plus 4 is 0. 1 plus negative 4, negative 3. 0 plus 2 is 2, 0. The other one is 2 and 1 is 0. Maybe R2 minus R3. So 0 minus 0, 0. 1, 2 minus 2R3. 2 minus 2 is become 0. Negative 2 minus 2 is negative 4. And negative 2 over 3. And then 0, 0, 1, 1. So the inverse is negative 3, 2, 0, negative 4, 1, 1, 0, 2, 3. This is the inverse. Okay. How to check? Okay, how to check? You can check, multiply the A inverse. It should be the identity, or A inverse A should be the identity. So you can multiply this with the original A. It should be the identity. Identity is 1, 1, 1, 0, 0, 0, 0. Okay. It should be the same from left and from right. The last part for today is the matrix equations. So this is the inverse. Another part is the matrix equations. So you have, for example, you have x minus 2y minus 4z is 7. 2x minus 3y minus 6z is 5. Negative 3x plus 6y plus 15z is 0. Okay, we can write these equations into the form of matrix equations. So we can write all the constant and let's write x, y, z. So this form is called the matrix equations. So this is the A, this is the x, this is B. Okay. So AX is equal B. This is called the matrix equations, the form. So let me write the so if you have the matrix equations like this, okay, remember that A, B is matrix. So all A, B, X is matrices. So X is okay. So in matrix equations, one thing that you will see here is you need to remember A and B and X all is a matrix. Okay. So if I say what is X, it's not B over A. Okay. It's not B over A. Okay. Please. Okay. Please. This is matrix form. Okay. And how to solve X? Yes. Yes. You can eliminate A or B if you multiply by the inverse, right? And remember, multiply from left and multiply from right might, but for the same result like A inverse or A inverse A, it's still the same identity. But in this case, because it has the X, choosing left or right becomes important. Okay, like maybe if you want to multiply by the left side, A inverse, it will be identity, right? But the B, you need also to multiply the same side. Okay. So let me write down. So if you want to multiply the A with A inverse, this should be done. Okay. And this become identity. So X is A inverse B. Okay, I think this will wrap up all the today's lecture up until the matrix equations. The next section of the matrix will be the determinant and the Cramer's rule. I think I can finish that next Tuesday, and we can go to another. I think another section, another chapters. Um, Actually, in the same page, in the same chapter, we still have the partial fractions and system of nonlinear equations, but I think I will skip that. And also inequality. I think I'll skip that. So the matrix is only until the determinant and the Cramer's rule. And then we can move to sequence and series. And if we still have time, we can go to the vectors and maybe just reviewing the important thing in vectors, because you already have the basic in the physics. Okay, so I think I'll up until here is our lecture today.